Hello, welcome to lesson 38. Yes, there is a typo here. This is really lesson 38, not 36, and we're going to be going over section 5.2. That's all about correlation. So you are encouraged to read pages 227 to 235 in the textbook. So let's talk about correlation first. If the ordered pairs x, y tend to follow a straight line path, there is linear correlation, or just correlation for short. So correlation is about how well a line can fit your data. A positive correlation is a relationship between two variables where one variable increases, the other also tends to increase. The more time you spend running on a treadmill, the more calories you will tend to burn. So we use this word tend a lot with the description of this. Taller people tend to have larger shoe sizes. The longer your hair grows, the more shampoo you will tend to need. So this means we're talking about on average. So the word tend is another way of saying on average or in general. A negative correlation means that there is an inverse relationship between two variables. When one variable increases, the other tends to decrease. A student who has many absences tends to have lower grades. As weather gets colder, air conditioning costs tend to decrease. If you suspect a correlation exists between two variables, it can be measured with the correlation coefficient. The correlation coefficient, R, little r or big R, either one, but our calculator, TI-84 calculator, I'll put TI-84 calculator, uses little r. But the textbook we have uses capital R, is a measure of the form, strength, and direction of a scatter plot, all combined in one number that's between -1 and +1. Here's example 1. Using the 8 graphs below, describe the relationship between a scatter plot and its correlation coefficient. So this first scatter plot has a correlation coefficient of 0.33. The second one is 0.69. The third one is 0.98. And the fourth one is 1.0. Down below we have -0.08. -0.64, -0.92, and -1. So notice the patterns. How are these numbers related to the type of graph that we see? So, for example, this one down here that has a correlation of -1, this doesn't mean that the slope of the line is -1. So let me write this little description here. But it means that there is a line with a negative slope that goes through every point. Calculating this correlation coefficient R involves multiplying the z-scores for the x and y coordinates of each ordered pair, adding up the products, and dividing by n-1. Fortunately, while we can compute the correlation using the formula, we will usually perform the calculations on a computer or a calculator. For graphing calculators, the correlation coefficient can be computed with linear regression t-test command. Here's example 2. Use the formula to find the correlation coefficient. The mean for the x values is 2, and the y values is 5. The standard deviation for both is 1. So let's figure out the ordered pairs for each of these points. This first one is 1, 6. The second one is 2, 4. And this third one is 3, 5. Okay, so let's find the z-score for all of the x values. So we're going to take the x value of 1 minus the mean, which they told us was 2, divided by the standard deviation, which they told us was 1. So this equals -1. We'll do the same thing for the next one. 2 minus 2 divided by 1 equals 0. 3 minus 2 divided by 1 equals 1. Now we'll do the z-scores for the y's. 6 minus the mean, which they told us was 5, divided by the standard deviation of 1, which they told us. This equals 1. 4 minus 5 divided by 1 equals -1. 5 minus 5 divided by 5, divided by 1 equals 0. Now we're going to multiply these two z answers together. So -1 times 1 equals -1. 0 times -1 equals 0. 1 times 0 equals 0. So the correlation coefficient R equals -1 plus 0 plus 0, all divided by the sample size minus 1, so 3 minus 1. So this simplifies to -1/2, or -0.5. Now you could find this same answer in using a calculator. If you want to use a TI-84 calculator to find this same linear regression, what you would do is create two lists. So create list 1 for the x values and list 2 for the y values. You can do that by going to Stat and then Edit. After that, you will go to Stat and then Tests, and then choose the Linear Regression t-test option. And then where it says X list, you will enter list 1. Where it says Y list, you will enter list 2. Where it says frequency, you will enter 1. And then it will say beta and rho do not equal 0. And then regression equation, just leave that blank. And then select calculate. If you go to the bottom of your results after you click calculate, you will see that little r equals negative 0.5, just like we got in our answer. Here's example 3. Calculate the linear correlation coefficient R for the following set of data. So this time we are going to, I'm just going to write down those instructions again for using a TI-84 calculator. Again, if you don't have one of those, a built-in calculator will be provided to you inside of the WAMAP questions. So the X column will be list 1, the Y column will be list 2. Remember, you can access those lists by going to Stat and Edit. Then you will go to Stat and then Tests, and then choose Linear Regression T-Test. So your X list is list 1, your Y list is list 2, frequency is 1, beta and rho do not equal 0, regression equation, and then select calculate. And then you will get an R equals 0.795. So how do we interpret this R value of 0.795? One way to interpret R is in terms of focus. Values close to +1 or -1 will have very clear pictures. Values close to 0 will often look like a vague swarm of dots. So this picture is about what we would have seen in our example 3. So example 3 had an R value that was 0.795, which is very close to 0.8. So we would have seen a picture sort of like this if we looked at the scatter plot. However, a correlation coefficient close to 0 can mean other things, such as not a nonlinear pattern. It can't be emphasized enough that the scatter plot must be analyzed first before making any conclusions about the correlation. So all of these graphs down here of scatter plots have an R value of 0, but you can notice that some of them do have patterns. They're just not linear. Here's example 4. Match the calculated correlations to the corresponding scatter plot. Okay, so let's start with A. A is an R value of 0.49, so we're looking for something that has a positive trend. So the only one that has a positive trend, it looks like, is number 2, because it looks like it's sort of heading uphill. So I would mark this one as A. Part B, R equals negative 0.48. So we want something similar to A, but it's heading downward in direction. So I would think that number 4 is a good candidate for B. C, R equals negative 0.03. This one is something that is very close to 0, so it should look like something that's almost not linear at all. So this number 3 would be a good candidate for C. And then what's left is R equals negative 0.85. So this should be more of a negative sloping line that's more condensed. So this number 1 graph would be a good candidate for D. Now, I went from start to finish and just chose the graphs as I went along, but the easiest way to start with something like this would be to start with ones that are closest to 1 or -1, because those are going to be the ones that are most condensed around a straight line.